I'm going to record too. All right, logarithmic functions for graphing. We need to think inverses, right? So we know how to graph the exponential function y is equal to whatever to the x, right? We are going to use that particular graph and that particular table that we create in order to help us with graphing our logarithmic functions, because logarithms and exponential functions, they are inverses of each other. So let's refresh our memory about what that means. Think back to when we did work with inverses before. To find our inverses, remember we switched our x's and y's, and then we solved again for y. So domain became our range became our domain, switching x's and y's. So just kind of keep that in the back of your mind, right? Okay, so if we are looking at the graph of y equals 3 to the x, so this is what you are going to be asked to graph on your quiz day 2. So if we have something like y equals 3 to the x, I want you to think about the table of values that I'm going to expect to see. I'm going to expect to see this -1, 0, 1, right? We're going to plug those in. So 3 to the -1, 3 to the 0, 3 to the first, right? We're plugging those values in. To graph that, where's our asymptote for any exponential graph? Where, Jacob?
0.
Y equals 0. There you go. So y is equal to 0 is our asymptote for any exponential graph unless there's a shift, right? And then we are graphing. We're going left 1 and barely up. We're going up to 1, and then we're going over 1, up 3. And let's go ahead and graph that. Boop. That looks about like that. Right? I'm going to want to see that table. I'm going to want to see those points. All right, that's just our basic exponential graph. The inverse of that would be y is equal to log base 3 of x. Okay? Think about that for a second. If I asked you to rewrite that logarithmic equation in exponential form, right, it would give us 3 to the y is equal to x. And if you look at what we started with over here, we've just switched x and y is all that's happened. So they are inverses of each other, right? So kind of keep that in the back of your mind. We're going to basically switch our x's and y's in order to do our graphing. So to graph this 3 to the y equals x or y equals log base 3 of x, it could be written either way. But what it means we're going to do is switch our x's and y's. So from our table off to the left there, we're just going to switch our order. Excuse me. We want to graph those points. So barely over and down 1, right 3, up 1. And that graph looks about like that. Guys, if the asymptote for this exponential equation was y is equal to 0, what do you think the asymptote would be for this inverse graph? There you go. It should make sense to you then that this is going to be x is equal to 0, right? So the asymptote for a logarithmic graph will always be at x equals 0 for the basic graph. If we're shifting, then it might change, right? Okay, let's take a look. It's mentioning this line. Remember, the line y equals x is our line of symmetry for these graphs. Think about where that is. I'm going to draw that in lightly. And I'm actually I want to shift, like move this. If you want to tilt your paper or take a look at that, like that you should see the symmetry there, right? That's the other thing we notice when we are looking at inverse graphs is that symmetry. Hopefully that rings a bell. Okay. So to graph any logarithmic graph, what we are first going to do is think about its inverse, its exponential table, and then we're going to flip it. That's the process that we're going to use. Okay? Questions, comments? All right, let's take a look at a little bit more. I've got a bunch of examples. If you look, we are not going to go through all of those. Let's talk properties for a minute. So properties of logarithmic functions. Think about what we learned about our exponential graphs and what our domain and range is for those. And it should make sense to you that our domain and range switched. What was our domain becomes our range, etc. Right? So our domain for logarithmic functions is from 0 to positive infinity. Our range is all real numbers from negative infinity to positive infinity. That is just the switch of the inverse of our exponential graphs, okay? Think about where our x-intercept is, and think about where our asymptotes are. Don't worry about that other stuff. But you need a good visual. You don't see logarithmic decay very often. You do every once in a while see a graph of logarithmic decay. For the most part, though, you are going to end up seeing this logarithmic growth. So asymptote here, and then this branch to show the logarithmic graph. So you need a good visual picture of that in your mind, because that's the graph we're looking at for the time being. Okay? And that's kind of what they're showing here in that little middle area there. Key reminder here, key points for a logarithmic graph. Think about what your key points were for y is equal to b to the x. So if we look at our negative 1, 0, 1, then b to the negative 1 just gives us 1 over b. B to the 0 is 1. B to the first is b. Right? Those are our key points for our exponential functions. So the key points for our logarithmic functions, we're just going to switch them. Right? So x and y, that means over here is where our negative 1, 0, 1 goes. Right? 1 over b and 1 and b. Okay? Everything that you've learned about translations, shifting, up, down, left, right, stretching, reflecting, all of that good stuff, it's the same for logarithmic graphs, just like it has been for any others. So no changes with respect to that. All right, let's take a look here. And we are going to look at all three of these. The formatting of this got messed up. So I need you to notice that part of this equation over here got moved down to that next line. So cross that out over here and add it over here, because that's the graph we're going to do. Does that make sense? It just kind of moved to the next line. Somehow the formatting got wonky. Okay, if you notice, take a look here. I need you to notice all of these are a log base 3 that we want to graph. What that means is we want to come up with a table of values for y is equal to 3 to the x. That's our first step. So y is equal to 3 to the x, and let's do our table. So 1/3 and 1 and 3. Okay? So that's our exponential. It means from there we need to think about how we are going to think logarithmic, which just basically means we're switching our x and y. And this is, guys, this is a key step, because it's really easy to get distracted and not remember to do that inverse, and then you're graphing the wrong thing. So do be careful of that, okay? So we're going to use that table of points, and we're going to look at all of these adjustments that are happening here. So for this first equation, what is that negative 3 up front telling us is going to happen? Trevin, what does that mean? What do we change?
So
If we have a negative out in front, what does that make, what does that mean? What does that happen?
It's gonna be like a decay kind of?
Okay, it's gonna reflect, yep, so it's gonna reflect over the x-axis. So the process is, it is gonna look more like decay, you're exactly right. We're gonna reflect it, it means we're gonna multiply the y's values times -1, right? So when we graph these points, we would normally graph 1/3 comma -1, but we're multiplying that y times -1, so we're gonna go 1/3 and then we're gonna go up 1. And then 1, 0, and then 3, -1. So yeah, this graph looks more like a decay graph, doesn't it? It's, technically it's not, but I understand what you were saying. You were just saying it's going down instead because of the reflection, right? Good, okay. No change here in where our asymptote is, so we're still at x equals 0. So that's that one. Okay, Tommy, what about this +1 here? What does that mean is happening
Where?
in that next equation?
Isn't that right one or left one? So that's up one.
That's up 1, there you go. So, guys, the only difference in this graph is we're gonna draw crosshairs. We're shifting up 1, and we're gonna draw our points from there. Question, is our asymptote gonna change, where our asymptote is? Uh-oh, I'm hearing a yes and I'm seeing a no shake of the head. Which is it? If we're just shifting up 1 and we're not going left or right, is our asymptote gonna change?
Yes, no.
Uh-oh, I'm still hearing 1 yes and 1 no. Let's figure this out.
The logarithm though.
Yep, for the log graph, our asymptote is generally at x equals 0, right? So it's an x value. So if there's something that is adjusting our x, in other words, our left or right, then our asymptote will change. But in this case, that +1 is just shifting us up. It's not shifting us left or right. So the asymptote will not change. So we're still going to be at x equals 0 for our asymptote. Okay, and we're going to draw from this new crosshairs that I drew up 1. Now that's where I'm going to draw and plot these points down here. So 1/3 -1, 1, 0, 1, 2, 3, up 1. Let me draw this in a different color. So that graph's going to look about like that. Okay. What's happening in that last one? Brock, how are we shifting in this last one? Where? I'm sorry? Okay. Wanted to make sure I heard you correctly. Good. Left 1. So what's our new asymptote, Brock? There you go. Good. X is equal to -1. So that means our new crosshairs, our new starting position is just one place over from our origin, and we're graphing, still graphing these same points, right? So we're gonna go over 1 down, over 1/3 down 1, over 1, 1, 2, 3, and up 1. Let me change colors here. All of those look pretty similar. Hopefully you see the connection between this log base 3 of x with just those shifts. Okay. All right. Questions? All right. The next page looks daunting. It's not going to be as bad as it looks. We're not going to do all of these. Let's, we're going to look at um, these three to begin with. We'll talk about down at the bottom too, but we're gonna focus our attention on those three. Okay. Hola. First step, I put this little hint here to try to help you with this. If you need to write some hints to yourself, then please do. What's the first thing that we need to do here?
Right one.
Okay, write 1 and up 2. I like that. We'll do that. We can do that. Okay. We need to make a table of values. What's the equation that we're going to use to do the table of values? Gates, what do you think? I'm going to give you a hint. We have a base of 5 here for that log. Yep, we want to do the table of values for y is equal to 5 to the x, right? Whatever that base is, that's what we're using as our base for our exponential. So y equals 5 to the x. We're going to do that table. 1/5, 1/5. But then what? Nick, what do we do next? Yep, we're going to flip all of that because we really want to think log base 5 of x. So we're switching those values. So that's what we're graphing, those points. And Tommy's already told us to shift. I think it was Tommy. Was it?
What? Fast. Yeah.
Okay. So we've already shifted right 1 up 2. Tommy, what does that mean is our asymptote is?
It's at 1.
X equals 1. There you go. So asymptote's here at x equals 1. And we're going to start at that new crosshairs that we have, and we are going to graph those particular points. So let's do that. So barely over 1. 1, 2, 3, 4, 5, up 1. Boom. Nice. If you notice, the base for both of these is exactly the same. It's 2. So Larry, what's the table we're going to do first?
Y equals 2 to the x.
Great. Y equals 2 to the x. So 1/2 and 1 and 2. And then what do we do from there? Ari. Yep, we've got to switch it. So y equals log base 2 of x. So 1/2, 1, 2. These are the points we're going to use. Guys, try those two for yourself. You've got your table. Think about what your shifts are going to be. Jacob.
On the flip grid, can I just write the second table, or do you want me to write the first one too? And then write this.
As long as I'm seeing this table,
Yeah,
that's
like,
what I'm going to be
definitely write that
concerned
down.
about.
Okay.
I'm going to want to see this particular table. If you need to write this table, then by all means do it. If you don't need to, then for me though, I'm the type that it's like, I want to make sure I've got, I have to be very methodical in my work, or I'm going to make a mistake, get distracted, and then I'm going to accidentally graph an exponential as opposed to a logarithmic graph.
Thanks, Ash.
Finish those two first for me, please, and then go. You've got both of those done. Okay, bring it here. I want to see them. Okay, I think most of you have finished. Some of you are still finishing up a little bit, but most of you have finished already. Take a look. You should be right 2 and down 2, right? That asymptote labeled at x equals 2 for the number 2. And then for number 3, you should be left 3. Okay? All right, questions on those? We're doing some repetition here, but that's a good thing because I'm hoping the repetition is going to help you remember what this basic logarithmic graph looks like, right? The repetition helps with that. We need it in the memory banks. All right, common log, what's the base understood to be? 10, because we are in a decimal number system. Good. So we're not going to graph either of these, but think about the fact that what you would start with is y is equal to 10 to the x, and you would do that table. And then you're going to switch to do your y equals log of x, and you're switching, right? We're not going to go through that, but just reminder, similar process. Think about what's going on here. This is saying shifting which direction? Right, 1, good. And we would multiply our y's in this table by 3 in order to deal with that 3 there. Okay? All right, one last thing we're going to look at on the next page. We've got natural logs also, right? So remember ln, natural log ln is log base e. So what that's telling us is the initial table that we're going to write is y is equal to e to the x. And I'm hoping that you're seeing the repetition with this and can remember this part of it. That means we have 1 over e, which we're going to think of as approximately a third. And then e to the 0 is 1, and then e, which we know is, if you want to just put a 2.7 there for convenience, that's fine. Okay, that's the exponential. So y equals ln of x. We're switching. And so we're going to have our approximately 1/3, our 1, and our 2.7. That's what we're using as our points. And then this one we don't shift at all. We're shifting up 3 here, and we're shifting left 1 and multiplying by 3 there, right? Okay. What do you think? Not too bad, right? Okay, so let me explain.